Hello, we will show you with a simple model how important it is to make the right calculation when using a Monte Carlo simulation. So we will begin with a model. We have here three events considered as a cyber attacks with corresponding likelihoods described as a pure Poisson distribution, and we have also the corresponding severity. So for the first one, we see here the possible outcome of a Monte Carlo simulation with 1000 iteration with the predefined Poisson distribution. If we rerun the corresponding simulation again, we will see we have different values concerning the outcome. So the same applies also for the severity, which is described as a log normal distribution with the corresponding thresholds or the corresponding mean and the standard deviation. So in this case, we have here a possible outcome of an average 1.5 million Swiss francs. So considering the three events and the corresponding likelihood and severity, our question is, how is the outcome or how are the possible outcomes considering manifold of likelihoods and severity for each different events. So what we can do now is to make a comparison of the corresponding outcome with an alternative outcome where we have a price or a price mitigation strategy. So suppose that a company offers secure where it halves the corresponding likelihood of event 1 and of event 3, but it costs 300,000 Swiss francs per year. So this is the main purpose of the Monte Carlo simulation, is to make or to guide us to make better decisions on uncertainty. So uncertainty, therefore, because likelihood of the events are uncertain, or the number of events per year are uncertain, and also the corresponding severity outcome. So, but what we are doing is to look at two form of calculations. The first one, which we called without mitigation, with mitigation, correspond to the right calculation, where we have to combine the likelihood and the severity as described below. And the second one is a technique that multiplies directly the likelihood and severity. See below again. So we will make the corresponding multiple simulation, and we start here the corresponding simulation. As we can see here, the first two ones are very near corresponding to the outcome, and the last two calculations we can see a very dispersed outcome here regarding the different likelihoods and severity that has been multiplied together. So what is the corresponding result? First of all, what we have to do is some math or some calculations. So assume that we have here the strategy without mitigation. We can see that there's a nearly 10% chance or probability that the cyber attacks exceed 2.5 million Swiss francs. 2.5 million Swiss francs is a threshold that we have defined considering our free cash flow before cyber attacks. Then with mitigation, this residual is reduced to 1%. So there's a 1% chance that the cash flows at the end will be below 0 francs. So we have 1% probability that the company will end up at default. However, if we would use the false way to calculate the expected outcome or the corresponding outcome, we will see that without mitigation strategy, there is ex ante probability of 70% that the that the outcome will exceed 2.5 million Swiss francs. And without convolution or without compound function, there is with mitigation strategy at least 5%. So if we like to reduce our exposure to a 1% threshold, then we should always stay fine with the mitigation strategy paying 300,000 Swiss franc per year. However, if we would use the false calculation of the flawed calculation without convolution, so we have to pay much more for the mitigation strategy than is necessary. So that's all. We have shown here how to use the Monte Carlo simulation to make proper decisions under uncertainty. So if you have any questions, don't hesitate to contact us at mcflo.ch or support mcflo.ch. Thank you very much and goodbye.